CAD drafters and designers can find themselves going back to pseudo-custom CAD drawings that require slight changes from customer to customer. This repetitive task can eat away at time and therefore the drafter or engineer's ability to work on other important projects. Fortunately, there is an alternative option. Through the use of Python and a few add-on libraries, you can bypass CAD by developing code that generates PDF drawings with some variable dimensions. The best thing is, it's all open source and free. Please watch on to find out more. Hello, my name is Maury, and this is a look at an alternative to CAD drawings. Often, drafters and engineers need to make drawings over and over that are very similar to each other. This is a problem as this can cause a lot of busy CAD work, which takes time. There are many ways to approach this issue, but today I will be showing you how to convert that CAD into code, Python code in particular. For this video, we will be automating the drawing process of making an axle for a wheel. Wheel axles can be impacted by the bearings used to hold it in place, the load on the wheel, and tons of other little things. I could see a nightmare scenario where some CADer is making 2 to 5 of these drawings per day as the company is making them piecemeal. To do this, we'll need a library with the ability to create PDFs for us. For those not in the know-how, Python and other coding languages allow you to pull in libraries that other people have made that make things much easier to do. The ones we will be pulling in are Reportlab and Drawportlab. Wait, I know what you're thinking. Coding is scary. But before you go, Python really isn't that hard. There are tons of videos for setting it up and getting it on your computer, so you'll not be alone at the start of this journey. If you can use the CAD program, you are smart enough to code. Just a side note though, I will not be going over how to set up Python on your computer. I will only be going over the basics of this library and good practices for how to use it to generate drawings. If you would like to have a video on how to get this set up and running on your computer from beginning to end, please let me know in the comments below. Otherwise, ask ChatGPT how to download VS Code in these libraries on your computer. It was made by coders, so it actually seems good at that, unlike how it is with mechanical engineering applications. That's a mood. Reportlab is a Python library made for generating PDF drawings. It's got a lot of cool stuff going on with it and a large amount of documentation. While the documentation is worth a look, the key section for us will be the draw operations. With this, we can turn our PDF into a canvas, like MS Paint or Inkscape, in which we can draw on with the code. We can make lines, shapes like circles and squares, text of any font, and much, much more. We can even pull in images if need be. With all these building blocks, we can make anything we want to show up on our canvas. For convenience, I've set up an add-on library known as Reportlab, in which I set up a lot of commands that do CAD things, like dimensioning and such. Don't be afraid to look at them or even make some of your own. Let's start with sheet format. We set up some boilerplate Reportlab code, add in the sheet format command, and it allows us to go from this to this. Briefly, let's talk about the commands around sheet format. The first section is the imports. Essentially, this is telling Python that we need to pull in extra commands and that they'll be coming from these libraries. C equals canvas.canvas formats and sets up the page for us. It tells the program the shape of the page along with the name of the PDF. C.showPage tells Python you are done with the current page. To get a multi-page PDF, all you need to do is have multiple of this function in the program. C.save tells Python you're completely done with the PDF. At this point, it'll go into File Explorer. Sheet format is where the magic of Reportlab starts to happen. This is a good time to go over the line command. Line takes in 2 locations on the screen and makes a line from one spot to the other. For this and all other Reportlab draw methods, the origin is in the bottom left corner of the page. The inputs for lines are points, a unit typically used in typography, so we'll need to convert it over into our unit of choice. Reportlab has a convenient variable built in for this, so let's pull this in. It's inches. Sorry, Europeans. So, sheet format is a function that contains a ton of these line commands put together, along with the drawString command, which works similarly, but with a focus on text. We also have c.inlineImage, which pulls in an image of our choice. Let's peek at the sheet format function itself. With the canvas command, we made a PDF that is 17 inches wide by 11 inches tall. Opening up the function, we can see how we made the title block. Every line that you see has the beginning and end points defined, with the origin being in the bottom left corner. All the text is located in a similar manner. Now we can start to set up the drawing for our axle. First, we bring in our dimensions of our axle as variables. For now, we will use a 1-to-1 scale for simplification. More on that later. Next, we need to set up the origin of our coordinate system for the first view that we are doing. This is not something that we do when making the drawing on CAD, but it really isn't that bad. All we are doing is defining a point from the bottom left corner of our PDF. This point will act as the origin of our current view that we are drawing out. In math, this is called a translation. At this point, we can start to code out our axle. We are drawing an axle, so even though it is round, from the side it looks like a rectangle. We will start with drawing out the first section. The rect command requires us to know the bottom left corner location, the width, and the height of what we are drawing. We need to do a little bit of math to get the corner coordinates of the first rectangle. We want this section centered with the rest of the axles, so we will find the top of our view and work from there. We can do this by pulling the max diameter that we will see. Section 2 will also be a rectangle. It will be further to the right, so we will use a variable to track where it needs to be in the x direction. With that, we can build the second section by pulling in its dimensions, and do the same with the third section. Finally, we do the fourth section, and now we have the full axle side view. We are far from done though, as we need to add in the dimensions. Looking at the dimension and extension lines, we can build a function that will allow us to make them. This is currently in Drawportlab for you to use. The centDim function requires the beginning and end coordinates of the dimension line and the text that needs to be displayed. Note that the text will need to be a string. To use this, we'll need to import the draw file and add in the code. Like before, we define all coordinates from our designated origin. Note that the dimensions are outside of our designated area for drawing, so we'll have to be careful if we want to add in additional views later. The centDim works for vertical dimensions as well. We will add this in for section 1. The rest of the sections are pulled in the same way. There isn't much extra to add here. The lines of code all effectively do the same thing, and are still pulled in from the origin that we designated. Looking back at our CAD drawing, we will also need a front view of this piece. Fortunately for us, it just looks like 3 circles. Reportlab's circle function requires us to know the center location and the radius of this circle. Just like before, we define the bottom left corner as the origin of our view. We will keep the same y coordinate as before, but adjust the x coordinate to the right side of the page. With this setup, we can now add in the 3 circles representing sections 2, 3, and 4. We don't have to worry about section 1 as it will be hidden from us in this view. And here we are done and never have to make another axle drawing again. This has been a fun project for me, so let me know in the comments what you think about it. I'll show a final example with one of my coworkers' most recent requests so you can see how the axle changes. All you have to do is change out the dimensions and... Wait, what? The side view bled right into the front view. This will happen if the total length of the axle is more than 9¼ inch, as that's all the distance we allow it to go on the page. To deal with this, we'll need to apply something called a scale. The scale is the ratio between the size of the drawing on the page and the size of the part in real life. In CAD drawings, this is usually just a button press to deal with. For us, we will need to code it in ourselves. Our drawing currently is a 1-to-1 ratio. In other words, the length of the part on the page is the same as the length of the part in real life. The nice thing about coding is that we can pick the way that we want to deal with this. There are several ways to deal with this, but I like to set the ratio to where the drawing is as big as possible. To do this, we'll need to define the maxed allowed size of our drawing and work from there. We take the max allowed dimension length of the view on the most important axis and use it to get the ratio from the page space to the real-world dimension. For completion's sake, we should also do this for the other axle and take the smallest ratio. So at this point, our code is hard-coded to be a 1-to-1 ratio from real space to page space. We will need to incorporate this ratio all the way through this thing to allow the views not to overlap. Ready? Radical. The code hasn't changed a whole lot. The major change is how the axle properties are pulled in and implemented. Previously, we pulled them in and immediately put them into this page space by multiplying them by inch. In a new version, we pull them in untouched, and whenever we need to use them, we scale them by multiplying them by the scale ratio, which we put as rat. So here we are. We've made a basic Python program that takes an input of 8 dimensions and outputs most axles that we want. With an upfront time investment, we have automated this process, freeing our time up to work on bigger and better things. Observant viewers will note that I do not have the cross section added from the beginning sting of this video. Well, this has been a lot to put on you, so I figured it was a good time to take a break. Now is a good time to point out that in a lot of cases, this is enough. Coding like this does take time, and there will be a point where the upfront cost of developing a program like this will not be worth the rewards. When I was in industry, I used this to develop initial basic drawings for customers. If they moved forward, I would then develop more thorough drawings through CAD software. So that is Reportlab and Drawportlab. To close out this video, I'd like to point out some advantages and disadvantages to doing things this way. The first advantage is that everything that I have shown is free. You can download this with a link below, assuming I figure out how to do it. Second, it is fast. Skipping the meshing step allows you to cut down in time. Third, doing it off Python allows you to get access to the wonderful open source world of Python. There are things such as graphics interfaces, there's ways to talk to Excel, and so much more. While I was making this video, I was having an interview with a company from a manufacturing engineer. I was talking to him about this program and how I was working on it and everything that I had done with it. And at the end of my spiel, he looked at me in the eyes and said, "So what is Python?" So I think I might need to make a video specifically for mechanical engineers on why Python is so good to learn. I don't know. Sounds fun. All right, bye.